All right, in unit number 4, we first encountered sequences, which just consisted of a specific list of numbers in a particular order. We extensively studied the idea of an arithmetic sentence, where each successive number in the last was generated by adding the same quantity to the previous number. So let's do warm-up. Exercise number 1. An arithmetic sequence is defined recursively by the following formula, where the first term is 5, and each additional term you add 3. So, find the next 3 terms of the sequence. So, if my first term is 5, then what are my next 3 terms? 1, 2, 3. So, each one you add 3. So, 8. 8 plus 3 is 11, plus 3 is 14. Find the value of A20 without listing all 20 terms. So if our first term is 5, and our second term is 5 plus 3, and our third term is 5 plus 3 plus 3, then really what you're doing each time is you're just multiplying by 3 each time, but by how many times? So A to the 20th is our first term plus 19 more terms times 3. Well, 19 times 3 plus 5 is 62. So the reason why we don't multiply by 20 and instead we're multiplying by 19 is because we're adding our first term already. So clearly, arithmetic sequences share many characteristics of linear functions. In fact, arithmetic sequences are examples of discrete linear functions. Exponential functions have their own discrete versions, and those are called geometric sequences. They have a very simple recursive formula. So when you're given the first term of a equals 1, or a of 1, then each successive term can be found by a of any number is a of the first number minus 1 times r, where r is some constant, which is the common ratio of the sequence. So we're going to practice this. Our first one, to go from 2 to 6 and 6 to 18. Remember, since these are geometric, that means that it is going to be either multiplying or dividing. Well, it's getting larger, so we're multiplying. 2 times 3 is 6. 6 times 3 is 18. So 18 times 3 is 54. 54 times 3 is 162. So our r, what's happening each time, is it's multiplying by 3. Then our next one, we go from 4 to negative 20 to positive 100. So if it's going from a positive to a positive, that means each time it's multiplying by a negative. So we can go, all right, what's going on each time? Well, times 5, times 5, times 5. So times negative 5 is negative 500. Times negative 5, 500 times negative 5 is positive 2,500. So our r is negative 5. And our last one, it's getting smaller. So that means that we're going to need to, it's dividing each time, or it's going to be a fraction. Well, 16 divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. Divided by 2 is 1. So each time it's going up by 1/2. As with arithmetic sequences, we should be able to predict any particular term in the geometric sequence by thinking about how many times we've multiplied by the common ratio r. So let's look at this sequence. The first term is 3, and then the formula is saying that each one is being multiplied by 2. So find b of 2, b of 3, and b of 4. So our first one is 3. We now need to find the second, third, and fourth terms. So our second term means you take the term before it and you multiply by 2. So we get 6. Then multiply by 2 to get 12. Then multiply by 2 to get 24. So each time it's multiplying by 2. Based on what would the value of b of 10 and b of 20 be? Well, we know that b of 2 was 3 times 2. and b of 3 was that answer times 2, or it was 3 times 2 times 2, or b of 4 was 3 times 2 times 2 times 2. So what happened each time is the first one actually was 3 times 2 to the first. The second one was 3 times 2 to the second. And the third time was 3 times 2 to the third. You will notice that none of these exponents really match what's going on here. But just like in the other formula, you have your first number already listed. So you're taking 1 away. So if I'm going to look at finding b of 10, isn't it true it would be my first number times 2, and it's going to be raised to the power that's 1 less than what we're looking for, so raised to the 9th power. So then b of 20 is going to be my first term times 2 to the 19th power. So 3 times 2 to the 9th power is 1536, and b of 20 is going to be 1572864. One thing you might have noticed in the last exercise is how quickly that a geometric sentence grows. Does this sound familiar? Let's look at a classic problem. So you just won a very strange lottery. The lottery promises to give you money each day for a 30-day month based on one of 2 options. You can either pick option 1, where you receive $1,000 on the first day, $2,000 on the second day, $3,000 on the third, in an arithmetic sequence. Option 2, you could receive 1 penny on the first day, 2 cents on the second day, 4 cents on the third, 8 cents on the fourth, etc., in a geometric sequence. Of the 2 options, which would result in the largest payoff on the 30th day only? So, the first one, so option 1, our first term is $1,000. So now we have to figure out our 30th term. Well, our 30th term is going to be $1,000 plus 29, and remember it's going up by 1,000 each time. So it equals exactly $30,000. Now we're going to look at option 2. Our first term is 1 penny. Our 30th term is going to be our original term, so our first term, times, well, did you notice that it's doubling? So it's doubling, and then take 1 off of 30 to get 29. You will find that it becomes 5368709.12. So which option would you choose? The second option. But if just looking at it, it seems like the first option would be more money. However, at the end of 30 days, option 2 is exponentially larger. All right, graphs of geometric sequences will look familiar because they're a type of exponential functions. So for a geometric sequence where the first term is 16, and each time it's multiplying by half, list and plot the first 6 terms. So 16 is my first term. My second term, you divide it by 2. My third term, you divide it by 2. My fourth term, you divide it by 2. So 1, 2, 3, 4, fifth term, divide it by 2. And my last term, again, you divide it by 2 to get 1/2. So we're not going to plot this. So if my first term is 16, and my second term, so goes up 1, 2, 3, 4, 5, 6, 7, 8, and then 4, and then 2, and then 1, and then 1/2. So you will see that it becomes an exponential graph.